Good morning, friends. Today we are going to see the Unit 1 wave optics of engineering physics. So, what are the electromagnetic waves? The electromagnetic waves are transverse waves traveling without a medium and through empty space also. Now, transverse waves have upper part that is called crust and lower part that is called trough. The distance between the two crust is called wavelength, or distance between the two trough is also called as wavelength. Then electromagnetic waves are waves created as a result of vibration of electric and magnetic field perpendicular to each other and perpendicular to the direction of propagation as shown in figure below. Red one is the electric field vector and blue one is the magnetic field vector. Both are perpendicular to each other and perpendicular to the direction of propagation. And as per the diagram, the distance between the two crust or trough is called wavelength. Then next point is electromagnetic spectrum. Electromagnetic waves can split up into the range of frequencies. This is known as electromagnetic spectrum. So smallest frequencies for radio waves and largest frequencies for gamma rays. Now with respect to that one, if the frequency is smaller, the wavelength will be larger. For larger wavelength for radio waves and smaller wavelength for gamma rays. With respect to that, their applications will be different. Okay, we'll see one by one. Radio waves. Radio waves are type of electromagnetic waves in electromagnetic spectrum with longest wavelength and having lowest frequency in all the electromagnetic waves. Its wavelength is 10 to 3 meter and 10 to 4 hertz frequency. A radio waves best known use for communication technologies like TV. The second one is microwave. Microwaves are shortest and having higher frequency than the radio waves. Its wavelength range to 10 raised to minus 2 meter and frequency 10 raised to 8 hertz. Microwaves normally used in microwave oven. Waves transfer energy to the water in food causing them to vibrate, which transfer energy in the form of heat. The next one is infrared rays. Radiant energy that's invisible to human eye but that we can feel as a heat produced when atom absorb and then release energy. Its wavelength is 10 raised to minus 5 meter and frequency is 10 raised to 12 hertz used in heat sensitive thermal imaging cameras. Infrared rays are created by ironing machine also. The next one is visible light. It is visible to human eye. It has shorter wavelength and higher frequency than infrared rays. Its wavelength starts from 0.5 into 10 to minus 6 meter and frequency is 10 to 15 hertz. Longest wavelength is red light and shortest wavelength is purple light or violet light. Then ultraviolet rays, it has shorter wavelength and higher frequency than visible light. It carry more energy than visible light. Its wavelength starts from 10 raised to minus 8 meter and frequency 10 raised to 16 hertz. It is used to kill the germs in the water. Then X-rays, it has shorter wavelength 10 raised to minus 10 meter and highest frequency 10 raised to 18 hertz than ultraviolet rays. It carries a great amount of energy and can penetrate most matter. Use of X-rays for engineers to check for tiny cracks in structure. The ray pass through the cracks and the crack appear dark on the X-ray film. Then gamma rays, it has shorter wavelength 10 to minus 12 meter and higher frequency 10 to 20 hertz than X-rays. Carry the greatest amount of energy and penetrate the most of the matter. Exploding nuclear weapons emits gamma rays that is used for the destroying the particular area of that nation. Then coming to the first point, what is interference? That you have studied in 12th standard, when two or more waves traveling in the same direction meeting at a particular point produce redistribution of intensity of light in the area of superposition of waves results in alternate bright and dark bands called interference. When two or more waves are superimposed, then what happens? Either they will impose in phase or out of phase depending upon their superimposing, they will produce alternate bright and dark bands. Okay, then conditions for stable state interference pattern, two sources must be: number one, monochromatic means having single wavelength. Then two sources must be coherent. Coherent means having phase difference 0 or constant and two sources must be close to each other, and fourth one, two sources must be equally bright. These are the four conditions for stable state interference pattern. Then types of the interference: constructive interference and destructive interference. Constructive means condition of brightness, and destructive interference means condition of darkness. Now when the constructive interference takes place, when two or more waves traveling in a particular direction meet at a particular point within phase, then addition of the amplitude in the resultant wave will take place. That is, in our diagram we have the amplitude AW1 for first wave and second one for AW1 dash for second wave. When both the waves are meeting at a particular point in phase, then addition of the amplitude will take place, and we get AR is equal to AW plus AW1. So AR is larger than the AW and AW1. That is for constructive interference. And destructive interference, when two or more waves traveling in a same particular direction and meeting at a particular point, if they are meeting at out of phase, then subtraction of the amplitude will take place, and the resultant amplitude will be smaller in comparison with the individual waves. For example, AR is smaller than AW and AW1. This is about the constructive interference. Constructive interference is for maxima and destructive interference is for minima. Okay. Then Stokes law. What is Stokes law? When light reflects from denser medium to rare medium, when light reflects from denser medium to rare medium, there is phase change of pi or path difference of lambda by 2 will be added or subtracted. For example, if your notebook which will contain the alphabets is kept in front of the mirror, the alphabet will get reverse. You will observe the reverse alphabets. That is because of the Stokes law. Okay. When light is reflected from rare to denser medium or transmitted, there will be no phase change occur. This is about the Stokes law, and then we will see the calculations for Stokes law. Phase difference is equal to 2 pi by lambda into path difference. Now when phase difference is pi, then path difference will be, if you substitute phase difference is equal to pi, pi is equal to 2 pi by lambda into path difference. So pi will get cancelled and path difference is equal to lambda by 2. When phase difference is 2 pi, 2 pi, 2 pi will get cancelled, so path difference will be lambda. When phase difference is 3 pi, then path difference will be 3 lambda by 2. When phase difference is 4 pi, after calculation we will get path difference, that is 2 lambda. Then interference in thin film. What is thin film? The film whose thickness is of the order of few Armstrong is called thin film. Armstrong means what? 1 meter, 1 Armstrong is equal to 10 raised to minus 8 centimeter, and 1 Armstrong is equal to 10 raised to minus 10 meter. Okay, so the film whose thickness is of the order of the few Armstrong is called thin film. An example of thin film: oil drop on water, that soap bubble. In rainy season, oil drop on road shows different color due to the interference that you're seeing in the slide. Coming to the next slide. Now here we are going to start with the derivation. Interference in thin film of uniform thickness. So what is uniform thickness? The thickness is constant. Now in our diagram we have the thickness for the thin film is T, which is constant everywhere. Okay, then S. What is S? S is the source of light, which is monochromatic source of light. The light is incident at an angle I with the normal on the thin film. Then what happens? Part of light get reflected and travel along AB, and part of light get refracted and travel along AC. Again from point C it will get reflected and travel along CD, and then it will emerge out and travel along DE. This is the description about the diagram. Then both the rays are derived